Now we're going to look at another stress to an equilibrium system, temperature changes. We should be able to predict which way an equilibrium system will shift when there is a temperature stress by the end of this video. We should already know about Le Chatelier's principle. Equilibrium systems will want to shift in a direction that will reduce a stress that is put on the system. Before we look at temperature stresses, I just want to introduce two terms since we are talking about temperature in this video. The first term is exothermic reactions. These are chemical reactions that produce heat, meaning that heat is a product. Exothermic reactions are the ones that tend to feel hot to the touch. The second term is endothermic reactions. These chemical reactions are ones that absorb heat. This means that heat must be a reactant. Endothermic reactions will feel cold to the touch. Let's talk about exothermic reactions first. In these types of reactions, heat is a product, so we can represent it with a plus heat on the product side of the chemical equation. If this example equilibrium system is stressed by increasing the temperature or heat, then there'd technically be too much product. So to relieve the stress, the system should shift in the reverse direction to reduce the heat. If we stress the equilibrium system by decreasing the temperature or heat, then there'd technically be less product now. To relieve the stress, the system will need to shift forward to increase the heat back. So the trick is just to treat the heat as a product. For endothermic reactions, we would treat the heat as a reactant. But here, I want to write it in a different form that you may need to recognize it as. In this example of an endothermic reaction, the 196 kJ stands for 196 kilojoules. Kilojoules is a unit of energy, so you can think of this as heat. Since the 196 kilojoules is on the reactant side, we can treat this heat energy as a reactant. Okay, so if this equilibrium system is at equilibrium and we stressed it out by increasing the temperature or heat, then there'd technically be too much reactant. The system will want to shift in the forward direction to reduce the amount of heat. Conversely, if the stress was a decrease in temperature or heat, then there'd technically be less reactant. The system would want to shift in the reverse direction to increase the amount of heat back. So again, just treat the heat as a reactant here for an endothermic reaction. Then you just applied Le Chatelier's principle like before. In this example, the chemical system above is at equilibrium. This is actually the same chemical system as in the last video, but in the last video I hid the fact that it was an exothermic reaction just to make things more simple. We're going to predict which direction the chemical system will shift if we increase the temperature. We'll also predict what color the chemical system would appear more like, more yellow or more red. If we increase the temperature here, then there'd technically be more product. Since heat is on the product side of the chemical equation, it'd technically be more product if we increase the temperature. So increasing the temperature will cause there to be too much product. The system will shift in the reverse direction to try to get rid of the heat. If the system shifted in the reverse direction, then the chemical system will appear more yellow because the Fe ion is yellow in appearance. Let's see this in the clip below. So the beaker on the right is actually a hot water bath. It's not being heated right now, but it was heated before, so it's technically really hot. And the test tube that's in it is the same chemical equilibrium system as the one that's not being heated right now. But you can see that there is a color change happening. Okay, it looks like there's a bit more of a yellow shade there. So yeah, we predicted this correctly. In this second example, we have the same chemical system. The only difference about this problem is that the stress is that it's now placed in an ice-cold environment. Doing this would cause a drop in temperature or heat. So if this happens, then there's technically less product now, since heat is on the product side of the equation. The system will shift in the forward direction to produce more of that heat back. This is going to result in the system appearing more red because the FeSCN plus 2 ion is red in appearance. Let's verify this with the clip below. Okay, so now that test tube is in a ice bath beaker, and there you go. You can compare and see that that chemical system is a lot more red compared to what it was originally. So we were able to predict that as well. Now it's your turn to practice this. Take a look at the endothermic equilibrium reaction. As before, figure out what the stress is, and then decide which way the equilibrium will shift according to the Châtelier's principle. Pause the video. In 5 seconds, I'm going to reveal the answer. There. Hopefully you found this relatively straightforward.